we're starting today's lesson with something called the helpful hexagon. The helpful hexagon is a tool for remembering all of the relationships for sine, cosine, tan, cotangent, secant, and cosecant. So we're going to start by labeling it along the top. We're going to put our functions in order. Sine, and its co-function across from it, cosine. On the next level, tangent, and its co-function across from it, cotangent. And on the third level, the bottom, secant and cosecant. In the middle, we're going to put a big number 1. Okay. And as you saw me writing them, sine, cosine, tangent, cotangent, secant, cosecant, we realize one of the things that this shows us are the co-functions. And there are some co-function rules. Remember, co-functions have angles that add up to 90. So we know that the sine of theta would equal the cosine of 90 minus theta. And vice versa. The tan of theta would equal the cotangent of 90 degrees minus theta. And the secant of theta would equal the cosecant of 90 degrees minus theta. So co-functions are across from each other. Those are our co-function identities. If I trace along the diagonals, so I'll do these in green, I've got sine equals 1 over cosecant. So these are called the reciprocal identities. I'll just call them reciprocals here. Again, if I start in the upper left corner with sine, and I go through the 1, I get that sine of theta equals 1 divided by, and it matches up with cosecant. Likewise, if I start at cosecant of theta, I would get that it equals 1 over sine of theta. So let's trace out all the reciprocals that we have. We're getting just a little crowded in here already. Get rid of some values with some lines. All right, let's put that 1 back in the center. And in green, sine equals 1 over cosecant. Cosecant equals 1 over sine. Cosine equals 1 over secant, and vice versa. And our tangents. Tangent equals 1 over cotangent, and cotangent theta equals 1 over tangent of theta. And the 3 you'd most likely be using is that cosecant equals 1 over sine, secant equals 1 over cosine, and cotangent equals 1 over tan. But you never know. All right, how else can the helpful hexagon help us? It can help us with what are known as quotient identities. And quotient identities, tan equals sine over cosine. So just trace an arc on that outside, and we start with tangent, and it equals sine over cosine. Likewise, if we start at cotangent, and we arc to the left, we hit cosine over sine. All right, so that's how it helps you there, the little arcs. Matter of fact, if you start anywhere and you go around the next 2, so in this case secant equals, it's cosecant over cotangent. But those aren't typically identities that we use for the types of problems that we're doing. Just get rid of that arc. There we go. And the last group of identities that this really helps you do, I'll put these in black, are the Pythagorean identities. Pythagorean identities are the things that had squares in them. And what we're going to do here is we're going to trace out some sevens. Watch, and I'll show you what we do. So sine cos to 1 is one of the sevens that I can trace out. And that identity is that sine squared theta plus cosine squared theta equals 1. Okay, so that 7, again, traces out the Pythagorean identity, starts with sine, but it's squared theta. We add the next trig squared theta, cosine squared theta equals 1 in the center. Let's find another 7 in our helpful hexagon. If we start at 1, we've got a 7 that goes to cotangent and to cosecant, so there's a nice 7 right there. And the pattern is the same. We add along the top. We did sine squared plus cosine squared, so we're going to do 1 plus cotangent squared theta and equals the bottom part cosecant squared theta. And the last 7 that we can find in here starts with tan. Trace out the 7. Number 7 does that. So that is tangent squared theta plus 1 equals secant squared theta. So the helpful hexagon is sort of a cute little way of remembering all this information. And all of this information is very useful in doing the types of problems that we want to do today. So identities, when we want to prove identities later on, they're equations with trig functions in them in this case, and what we want to do is we want to get the sides to be the same. So we're going to take this one, and we know from everything we just wrote down that tangent is sine over cosine. We know that cosecant is 1 over sine. And we can even change secant to 1 over cosine. Notice I'm doing my best to put everything, or every term, everything in terms of sine and cosine. Sine and or cos. That'll help you be very successful at these. So I changed tan to sine over cos, cosecant to 1 over sine. I used sine and cosine on all of these. So now a little arithmetic, I can reduce the signs, and then what I've got on the left is 1 over cosine, and what I've got on the right is 1 over cosine, and when the two sides match, that proves the identity. In letter B, let's see, 1 minus sine squared theta equals cosine squared theta. First I notice I have squares, and that's probably my Pythagorean set. Then I see I already have sine and cosine. So I'm going to look to this one for some help. Well, in this particular example, one really nice trick to get good at is to see that 1, the number 1, can be replaced with sine squared theta plus cos squared theta. So I'm going to substitute in right here for the 1. Sine squared theta plus cos squared theta. And I'm subtracting sine squared theta there. And hopefully this will equal cosine squared theta. And indeed, sine squared theta minus sine squared theta simplifies, and we have cosine squared theta equals cosine squared theta. A perfect match, and so my identity is proven. We'll do more of these on the next page. So for now, we just want to practice writing these or simplifying each of these little expressions and getting them in terms of sine and cosine. The directions say write each expression as a single term using sine, cosine, or both. So let's see what we have. Cotangent, go ahead and see if there's something you know equals cotangent. And you might do the helpful hexagon, or you might just know that it is cosine over sine. Cosecant, do you know this one by heart? If you said 1 over sine theta, good job. Tangent squared theta plus 1. It's squared. Looks like it might be one of these Pythagoreans. It exactly matches this, so we know it is equal to secant squared theta. And secant is the reciprocal of cosine. So there's your 1 over cosine squared theta. Remember, they wanted us to put them in terms of sine or cosine. Number 10. Tangent, I can replace. Matter of fact, looking ahead, I can replace each one of these in terms of sine and cosine. So let's do that. We've done these before in Chapter 9 and Chapter 10. You may remember them. So we're really just reviewing a bit here. Secant is 1 over cosine. And cotangent, the best way to express it here is using the cosine and sine quotient identity. Lots to reduce here. There's a cosine with a cosine, a sine with a sine. Multiplying across the top, we get 1. Multiplying, well, the only thing left on the bottom is cosine. So that is 1 over cosine. Excellent. Number 12. I'm going to get a little more complicated here. I have tangent over cotangent. So let's see, we could do this a couple different ways. Let's first write it this way, that I have tangent divided by cotangent. And here I might start to mess with these. Tangent and cotangent. Well, if you're trained to always use sine and cosine, then we should do that. There's a quicker way, if you want me to show you in class, but let's stick with our sine and cosine. So over here we get all ones. And over here we have tangent divided by cotangent. And when we divide two fractions, we do what? Multiply by the reciprocal. All right, so that's going to give us on the top sine squared theta, on the bottom cos squared theta, and of course we have plus 1. All right, well, do you want to do any more here? It is sine squared and cosine squared, but it's plus 1, so I don't have a single term. So what we could do is make our 1 into cosine squared over cosine squared, so that we have a common denominator for adding. So let's do that. So on the top, sine squared theta plus cosine squared theta. That looks familiar. All over cosine squared theta. And it's 1 over cosine squared theta. Whoop. Running out of room down there. There's a couple different ways to do this problem, but if we stick with the sine and the cosine, this is how it's going to come out. All right, and we have one more here, number 14 from the book. Secant, we know, is 1 over cosine. Try and be a step ahead. Oh, here's an interesting one. 1 over cosecant is sine theta. Let's put it over 1. Now to add fractions, we need a common denominator. So I'm going to need cosine, top and bottom. And then, of course, we have 1 over cosine plus sine cos over cos. And we're going to leave that, just put them together, all over cosine. Okay. So You want to know those identities real fast. You want to know them cold. The faster you are, the more you recognize, the better it's going to be. So on the next page, just a few questions. Did you need to know any of the identities from that helpful hexagon for these problems? Yes, of course you did. That's silly. Write 2 ways to express tan theta. So see if you can do these without looking. Tan theta. Let's see. Sine over cosine. Or what else? 1 over cotangent. Did you need to understand a use for common denominator? Yes, when we are adding and subtracting, or adding or subtracting fractions, you need to know that you need a common denominator. What is the common denominator for 1 over cos and 1 over sine? So if I were adding or subtracting these, I'd need a denominator of cosine sine. What is the equivalent of secant theta? 1 over cosine of theta. Did you need to work with fractions? Yes, we did a little bit at the end there. And the reason I'm asking that is because you have to remember that adding and subtracting fractions has important rules. And not only that, but multiplying and dividing fractions as well. So here's an example where we're dividing fractions. And you want to remember that when you're dividing fractions, write them out nice and slow, and then flip and multiply. Help you be successful. So write the steps to simplify 1 over sine divided by 1 over cos. So I'm actually just going to do the problem. I would write 1 over sine theta divided by 1 over cosine theta, and then realize that dividing by a fraction is the same as multiplying by the reciprocal, and we get cosine theta over sine theta, also known as cotangent theta, but we'll leave it at that. Which 2 trig functions are the easiest to work with? Well, that's sine and cosine. Every function can be written in terms of sine and cosine. Write the 2 other ways to use this Pythagorean identity. This is a good one. So sine squared theta plus cos squared theta equals 1 is the main identity. The 2 other ways that you might see this is if we subtracted sine squared over, then it would look like cosine squared theta equals 1 minus sine squared theta. Okay. And we could also say, let's subtract over cosine squared theta. And in that case, sine squared theta equals 1 minus cosine squared theta. These come up at interesting times. It's good. Notice when things are squared, and then hopefully you'll think about the Pythagorean identities and use them appropriately, of course. All right, you try this one. Can you recreate the helpful hexagon without looking back? And can you go through and figure out, starting with what the 6 values are, the 6 trig functions, and then tracing through it, walking through it, and getting all those identities. All right, so let's prove some identities like we did at the beginning. It says the 8 basic identities are used to prove others. This means to show that the 2 sides of an equation are identical. So there's lots of tips. Tip number 1, work with the more complicated side first. You can work with both sides, but maybe start with the more complicated. Number 2, use the basic identities to rewrite in terms of sine and cosine. Go for sine and cosine. Distribute whenever possible. It could help. So distributing this, for example, would certainly give you sine times cotangent we change that cotangent. Minus sine times sine is sine squared. So distribute when you see that possibility. Watch out for common denominators when you're adding or subtracting fractions. Simplifying complex fractions, remember how to divide as well. So we know when we're proving identities, and we'll skip around here a bit, that we're done when the two sides are identical. They have to be the same on both sides. All right, let's grab a few of these. I put a few extras in, but let's start easy with number 3. We've got sine theta. We're not changing it. Might help you to put it over 1. Cosecant, I will change. It's 1 over sine. Cosine, I'm not going to change. And I can see what's happening here. I'm looking to see if this equals cosine. I'm not going to change. Do a little arithmetic now. You've got your algebra, your sine and your sine. Those fractions reduce. On the left, you have cosine remaining, and on the right, cosine remaining, and they match. So we are done. All right, let's try another one. In number 10, I see that we should distribute. Let's distribute. Let's put a line down the center here so we don't cross it. I typically do that. So distributing here, sine times cosecant minus sine squared. Let's just work on this side. Cosecant is 1 over sine. I'm multiplying those, so that's good. Put that over 1. Minus sine squared, I'm going to leave that alone. My sine and my sine reduce. So I've got 1 minus sine squared theta. Now sometimes you'll just stop and look. What is it I'm trying to get the left side to look like? And I've got cosine squared on the other side. And I hope that you're noticing you've got squares. So let's think about the Pythagorean identities. And always remember, replacing a 1 is equal to cos squared theta plus sine squared theta. So I'm going to replace the 1 with cosine squared theta plus sine squared theta. I'm subtracting sine squared theta. So those are out, and we're left with cosine squared theta. And we've got a match. And find the smiley. Happy. They match. We are done. All right. Let's try number 8, which has a fraction in it. So this would be good practice for working with the fractions. First, we have 1. We're going to try to get the whole thing equal to sine squared. So I'm going to work on the left because sine squared is pretty simple. I have 1 minus. I'm going to write it as division. Cos divided by secant. So this is 1 minus cos divided by 1 over cos, because secant is 1 over cosine. Now I have 1 minus cosine times the reciprocal, which is cosine. So be real careful when you're writing these. Go slow with that division, and you'll end up being very successful. Well, we've got Pythagoreans again, squared, squared, and I've got a 1 again. So remember, 1 can be replaced with cos squared theta plus sine squared theta. That's the 1, and minus cosine squared was already there. Cosine squareds become 0, and you're left with sine squared. And zing! Happy, happy, they match. Awesome. Let's see what's on the next page. If I gave a little tougher one, we can go and do. And if not, we'll come back. Okay, there's some good ones here with lots of room Let's see, let's try 12 and 19, and then I think we're far enough into this video. You can try more on your own. Number 12. I'm going to work on the left-hand side. I've got tangent divided by secant. So I'm going to keep that division. I'm going to change tangent. Keep the division for now, because I need to change secant. Secant is 1 over cosine. Now flip that second fraction and multiply. Take your time. Cosines reduce, left with sine, and are we happy campers? Yes, we are happy. Happy campers. There we go. Not so bad, just take your time. Let's try 19, and then I've left some for us to try together in class. 19, let's see. Let's see which side to work on. 1 minus sine theta doesn't have much to do on the left, so let's work on the right. We've got cosine squared on the top, and we've got 1 plus sine on the bottom. So this equation actually has a trick associated with it. And the trick is to multiply the denominator, or to use the conjugate of the denominator, is a better way to say it, to change the look of that fraction. So then on the bottom, 1 times 1 is 1, and then I've got minus sine theta plus sine theta and minus sine squared theta. That's what I've got multiplying by the conjugate. On the top, I've got, I could distribute or not. Let's not distribute yet. Cosine squared times 1 minus sine theta. Let's see what happens with this denominator. Well, the middle terms drop out. That's what happens when you have a conjugate. And on the bottom we have 1 minus sine squared theta. So here we are again. It's really the third one we've done, where we have a 1 with a squared. And let's replace that 1. Do you remember what we can replace 1 with? It's cosine squared theta. Whoops, it's in the denominator, isn't it? So let me write this numerator. So I'm replacing this 1 because it's mixed with a squared. And I know I have another way to think of 1 minus sine squared theta. So cos squared theta plus sine squared theta minus sine squared theta in that denominator actually leaves me with cosine squared theta. These sine squareds cross out. Well, then I'm left with a fraction, cos squared times 1 minus sine over cos squared. I can reduce out these cosine squareds as well. And I'm left with 1 minus sine. And let's peek back up. Aha, that's exactly what I needed. So this one actually had a trick in it. And the trick might not make you smile, but try and remember it. We just used a conjugate. Okay? There's a few more here that aren't done. We'll talk to you tomorrow.